morning. So we're going to go over for braking efficiency. So it says, so a car is traveling on an asphalt road. So everybody, the drag factor does vary by the way what type of road you're on. So if you're on asphalt road, dirt road, gravel road. Okay, so it's so a car is traveling on asphalt road with drag factor of 7,800. So speed limit is 35 miles per hour. The brakes are working at 100% efficiency. The skid distance is 80 feet. Okay, we're going to use our skid speed formula. Okay, so we're going to have 30 times 80. Okay, because that's the skid distance, times our drag factor of 7,800. 100%, we're going to change to a decimal, so we're going to drop the percent sign and move the decimal to the left, okay, or you can divide it by 100. Okay, so we get 1. So we're going to multiply those all together. Everybody remember, you do need to do where you do the parenthesis so that it does multiplies all these first and then takes the square root. So we get 43 and 4,300, so 43 miles per hour. That's what we rounded to. So the speed of the car was 43 miles per hour for that one. Okay, what if we have multiple skid marks, everybody? So multiple ones. Okay, so what we do is we're going to find the average length. Okay, so or find the mean. So we have 3 skid marks of 35, 38, and 47 feet. So they find those 3 skid marks of the accident. So the forensic accident investigator measures them. We're going to add all 3 of those together. Remember, everybody, again, you do have to do that parenthesis around. Okay, so I can't emphasize enough, everybody. These parentheses, you gotta have them. Okay, so we put that parenthesis there. So it's going to be 30. We add those together, divide by 3, and we get 40 feet. Okay. So this one, we're going to solve for how long might the skid mark be. So we're solving for D. So we're going to take our formula and we're going to square each side. So that's how we get the speed squared divided by 30 times the braking efficiency times drag factor. Okay, so we're gonna, so Melissa's driving at 50 miles per hour. Okay, so that's her speed. The drag factor was 1 and 2/10. Okay, her brakes were working at 90% efficiency. Okay, so we're gonna drop the percent sign and go to left. So we're gonna have 0.9. So 50 squared divided by, and then everybody, yes, you have to do the parenthesis right there. Okay, so 30, remember 30 is just part of the formula, times 1 and 2/10 times 9, and we get 77 feet. Okay, so the skid marks might be 77 feet. Okay, so for this one, yaw marks. So yaw marks, everybody, are when they're curved. Okay, so the speed formula for that is speed is equal to 15. Yes, we do a parenthesis 15 times the drag factor times the radius. Okay, so R is the radius, F is our drag factor. Okay, so we're going to do, and then for the radius, this is our formula for this one. So it's the chord length divided by, chord length squared divided by 8. Yes, we have to do the parenthesis. 8 times the middle ordinate. You see the diagram up here. And then the middle ordinate divided by 2. Okay, so let's say, everybody, what if you had a chord length of 43 feet, a middle ordinate of 4 feet, okay, and a drag factor of 8/10? What's the minimum speed that they could have been going? Okay, so we first, everybody, have to solve for the radius. So 43 squared divided by 8 times 4. Yes, everybody, you have to put that parenthesis. Plus 4 divided by 2. Okay, we put that in the calculator and we get 58 and 8/10. And that's the radius. Okay, so everybody, that's our radius. So we're going to put that back into here. Okay, so now we're going to have our speed is equal to 15, the square root of 15 times 8/10 times 59 and 8/10, and we get 26 and 8/10, which we round up to 27. So the minimum speed, everybody, would be 27 miles per hour. Okay, everybody, you got this.